We just did a demonstration where we sent two wave pulses down, one from my end, one down from Jack's end, towards each other on the same side of the equilibrium position. In other words, we sent two crests down. We saw that those two waves went right through one another. If one wave is small and one wave is big, the small wave continued on through the big wave, and the big wave continued on through the small wave. They just kept going. But at the moment of intersection, at the moment where they were going through one another, we saw kind of an interesting pattern. We saw those two waves interfering with each other or producing a different size and different shape wave. Let's say that we have two waves going towards each other. First wave is going this way, the second wave is going this way, although it doesn't really matter. It doesn't really matter which way they're going. What matters is at a certain snapshot in time, these are their positions, regardless of which way they're moving. At this moment in time, we've got one wave going one way, one going the other way. What is the wave pattern going to look like as a result of the interference between these two waves? Well, we're going to use what we call the superposition principle in order to figure out what that wave looks like, in order to figure out what the size and the shape of this resultant wave looks like. And that superposition principle is easy. In fact, it's something that you could do in grade 1. All it requires is a little bit of adding. And the good news is the adding is easy. It's like 1 plus 3. You don't even have to add decimals usually, maybe a half or something like that. Work through this with me on the sheet that I handed out to you a few minutes ago. What I want to do is at every vertical line, I want to draw an X where the sum of the two waves is. So in other words, I want to look at how far above or below one wave is, how far above or below the other wave is, add them up, and then put an X where the sum of those two waves is. Now, ideally, you do this at an infinite number of positions, but realistically, we can't do that. So what we do is choose to do it at each of the positions that correspond to the vertical lines on this graph paper. All right, if we look at wave number 1, we'll make wave number 1, we'll call that wave number 1 this one, and we'll call wave number 2 this one. Wave number, the first vertical line here, we see only wave number 1. So we add those up. We add wave number 1 up to wave number 2, and all we get is wave number 1, because wave number 2 is not even there, right? Same deal right here, same deal right here, same deal right here, and here, because there is no wave number 2 in order to be added to it. But all of a sudden now, we've got wave number 1 and wave number 2 intersecting with each other or interfering with each other. So now we got to add them up. Wave number 1, you can see, is 2 blocks above. It's plus 2. Does that make sense? Wave number 1 is plus 2. Wave number 2 is 1 block above. So 1 block above and 2 blocks above gives me 3 blocks above. Make sense? 1 plus 2 is 3. If you're having trouble with that, you can pull out your calculator. I hope you can manage to do that one in your head. So look at the next one. Wave number 1 is how far above that heavy line? What is it? 2, good. Wave number 2 is how far above? 2. So what do we add those up to be? 2 plus 2 is 4. So we draw a little X 4 above. Wave number 1 at the next spot is 2 above. Wave number 2 looks to be about 2.5 above. So 2 plus 2.5 is 4.5. Wave number 1 is, well, almost 2 above, about 1 3/4 above. Right? You're estimating here to some degree. It's about maybe 1 3/4 above. Number 2 is about 2 3/4. 1 3/4 plus 2 3/4. Right? 1.75 plus 2.75 gives me what? 4.5? Is that right? So it's about 4.5. Might not be exactly, but it's close enough. Next one, we'd say, what is that, about 1.5. Wave number 1 is about 1.5 above. And then the next one is, wave number 2 is 3 above. 1.5 plus 3 above gives me 4.5 above. We've got a number of other positions here. I'd like you to finish this off, okay? These ones are easy down here, but there's a few more that you're going to have to do some addition for. Okay, finish those off, and then I'll show you what to do with that once we've finished those off. All right, let's see what that should look like now. All right, our next position, wave number 1 looks to be about 1.5 above. Wave number 2 looks to be about 3 and a bit. 1.5 plus 3 and a bit is like 4.6, 4.7, somewhere in that range. Right, 4.5, 4.5, 4.6, something like that. Next one we've got, well, what is the next one? It looks like about 1.25 above. And then we've got, what, about 3.25 above? 1.25 and 3.25 is roughly 4.5. Next one, what are we at here? A half a block above, and then we've got 3.25 above. 3.25 plus a half is about 3.75-ish. Going to look something like this. And then they get easy, right? Okay, they get easy. At this point, we just say, well, we got wave number 2, wave number 1's not even there. Wave number 2, wave number 1's not there, and so on and so on and so on. We keep going through there. Now, if we join those x's together, this is like grade 1 again, right? Okay, we were adding 1 plus 2. Now we're connecting the dots and seeing what picture we get when we connect the dots. The resultant waveform is going to look like this. At that moment in time, 1/10 of a second later, these waves are going to be at different positions, and the interference pattern that we're going to see is going to be different. At this snapshot in time, however, the wave pattern will look like this. You remember what kind of interference we called this when we were doing our demonstration? When two crests hit each other, we got a bigger waveform. That was called constructive interference. Constructive interference occurs when crest hits crest and you make bigger crest, or trough hits trough and you make bigger trough. Whenever you make bigger something, it's called constructive interference. Now, if we had two waves going towards each other, or whatever, it doesn't really matter which direction they're going again. But let's say they're going towards each other. Wave number 1, wave number 2, but one's a crest and one's a trough. What's the pattern going to look like now? Well, we're going to say that we only have wave number 1 right here, wave number 1, wave number 1, wave number 1, wave number 1, and so on. Oh, until we get to this point. When wave number 1 is 2 above, and wave number 2 looks to be about 2 below. 1 below. 2 above, 1 below. 2 plus negative 1 gives me 1. So they combine to give me that spot. Next one. Wave number 1 looks to be about 2 above. Wave number 2 looks to be 2 below. 2 plus negative 2 gives me, well, now we're doing like, this isn't grade 1 math anymore, right? 2 plus negative 2 is 0. Next one, what do we got? Still about 2 above, roughly, give or take a tiny little bit. 2 above. This looks to be about 2.5 below. 2 plus negative 2.5 gives me what? 2 plus negative 2.5 is negative 0.5. So we're going to put a little x at negative 0.5. I want you to go through that process now for the rest of these points as well. Keep in mind that we are dealing with negatives here. Wave number 2 is always below the axis, so we're going to call that a negative. When we add them up, make sure you take that into account and put the x where the sum of those waves are, and then connect them, and we'll see what we get. All right, let's finish this off as a group now. Wave number 1 looks to be about, I don't know, about 1 3/4 roughly, right? 1.75 above. This is about, what, about 3.25 below. 1.75 plus negative 3.25. Now the math is actually getting a little bit tricky, right? If you're having a little bit of an issue with that, though, that's okay to use your calculator, right? Negative 3.25 plus 1.75 is what? Would be negative 1.5, is that right? Negative 1.5? So we're going to draw this one at about right here, negative 1.5. Oh, wait. What did I just do, though? I did that wrong. I was looking at the wrong vertical line. Let's try that again. This is about 1.75 and 3. So that gives me about 1.25, right? You guys get that? About roughly 1.25, give or take a tiny little bit. You get this question on a test, and you will, by the way, on your unit test next Tuesday, get a question that's like this, okay, one of these interference questions. And you're off by the tiniest little bit, that's okay. If you draw it down here, that's not okay, because that's not right, down here. But if you draw it right here, give or take a tiny little bit, that's fine. I don't expect you to physically use a ruler and measure to the nearest 1/10 of a millimeter to decide exactly where that point should go. This one is, I don't know, about 1.5, a little bit more than 1.5, but let's say it's 1.5. This one is about negative 3.25. Yeah, that was the one we were doing. We had skipped one. And that gives me, what was that? 1.75, negative 1.75. So down about right here. This one's about 1.5 above. This one's what, about negative 3.25, roughly. Going to give me 1.75 below. Something like that. Next one looks to be about 1 above for wave number 1, and what, 3.5 below. Negative 3.5 gives me negative 2.5. And then the last one, not really the last one, but the last hard one, looks to be about 0.5 above and about 3.5 below. 0.5 plus negative 3.5 is negative 3. So we draw a little x about right here. And then these ones are easy, right? Because these ones only have wave number 2. Wave number 1 isn't even there. So join the dots, and we should get a pattern that looks like something like this. Should be pretty close to looking like this. What do we call this? Like, it's interference, right? It's two waves are making a different wave for that brief moment in time. But what kind of interference is it? It's not called constructive interference. Rather, it's called destructive. It's not, as a lot of people will like to write on your unit test, it's not called deconstructive. It's called destructive. You're effectively, at least temporarily, destroying a wave. You're making two waves smaller than they were before. Destructive interference. Now keep in mind that 1/10 of a second later, this waveform, this interference pattern is going to look different because these two waves will be in different positions. But at this snapshot in time, this is what the interference pattern is going to look like. Now the last one that I want to look at is a little bit of a different scenario. It's going to be constructive and destructive interference in the same diagram. Let's say we have 2-point source waves. 2-point source waves. So in other words, we've got something right here that's causing a circular wave to go out around it. And then we've got something right here that's causing a circular wave to go out around it as well. Does that make sense? Like when you drop a rock in the water, it forms a complete circular wave around the rock. Okay, we've got a rock that we're dropping right here, and we've got a rock that we're dropping right here, and they're both producing circular waves, crests and troughs. Right? Drop the, or dip the rock in, dip, 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 forming crests and troughs, crests and troughs, crests and troughs. But there's two of each, because we've got two rocks that we're dipping in the water. We're going to call these thin lines. These thin lines are going to be troughs, and these thick lines are going to be crests. You can see that there's a lot of places where the lines cross each other, where crests cross crests, and crests cross troughs, and troughs cross troughs. Where a crest goes over a crest, we get constructive interference. Where a trough goes over a trough, we get constructive interference. Where a crest meets a trough, we get destructive interference. So what I want to do right now is, with a couple of different colors, or for you guys, if you don't have different colors at your desk, use different shapes. Maybe one shape is an X, maybe one shape is a dot. Okay, I'm going to use colors. You might use shapes to indicate these points. Okay, but we're going to illustrate the same thing. For me, I'm going to say red is going to be constructive interference. For you, maybe an X is constructive interference. Does that make sense? We're going to do that? So what we want to do is go through this and identify every point where a crest meets a crest or a trough meets a trough. All those spots, like for instance right here. Okay, heavy line, or crest and crest meet each other, draw a dot. Or an X or whatever you're doing to indicate constructive interference. Right here, it's trough meets trough. That's constructive interference, and so on and so on and so on. I want you to go through and find every spot where crest meets crest or trough meets trough. Don't do anything with it. Once you've got those spots identified, just put your pen down, and then we'll take a look at it as a group, see what it looks like. All right, I've got a lot more spots that I can draw, so I'm going to finish that off now and see how it compares to yours. I'm going to start by continuing this one, okay? So we see a bunch of dots kind of right above each other here. Let's go over here. Remember, heavy, light lines. You guys see something like this? There's a pattern that's formed here. We'll identify what that pattern is in a few minutes. It's a little bit easier to see once we draw the areas of destructive interference. I'm going to choose a different color to draw destructive interference. You may choose to draw a slightly different shape if you don't have different colors. Mine's going to be green for destructive interference. I'm going to get destructive interference wherever crest meets trough or heavy line meets light line. So I'm going to draw those in now, or at least I'm going to draw a few of those in now, and I'm going to ask you guys to draw all of them in on your diagram. Wherever heavy line meets light line, or wherever crest meets trough, we get destructive interference. So finish those off now, and then we'll take a look at it as a group in a minute. I'm going to finish mine off now. Crest, trough, crest, trough, crest, trough, and so on. Start seeing a pattern forming here. We look closely at it. A little bit easier when we have different colors like this. Do a little bit of kindergarten work again, or grade 1 work again. Connect the dots. Connect all the green dots. We see something like this. We connect all the red dots, and we see something like this. in the honor of the Christmas season just ending. We get this nice colored, almost like a Christmas tree with green and red lights all over it. The red corresponds to areas of constructive interference. Lines of constructive interference. We call those lines antinodes or antinodal lines. If these were water waves that were interfering with each other like this, okay, like for whatever was causing the disturbance in the water was causing water waves like this, and you were lying on an air mattress on one of these antinodal lines, or these lines of constructive interference, anywhere along that line, then you would be bobbing up and down in that water like crazy, because the crests and the troughs would both end up being twice as big as a result of constructive interference. So you form one wave, you look out, oh, I can sit or lie on my air mattress with that wave, because that's okay. But now all of a sudden, because you've got two of those waves interfering constructively with each other, anywhere along those red lines, the waves become twice as big. Bigger crests and bigger troughs, constructive interference. Now these green lines correspond to lines of destructive interference. Which we could also call nodal lines. These are areas of complete destructive interference where crest meets trough and we get nothing, no wave. So this is the area where you lie in your air mattress and you don't bob up and down at all. The guy that's lying right here on this air mattress is bobbing up and down like crazy with crests and troughs that are both twice as big as a result of constructive interference. The guy that's lying on the air mattress right here is just enjoying the sun, reading his book, not bobbing up and down at all. So it's kind of weird to think, right? It's kind of weird to think about this, that as a result of this interference, you can get these areas of really big waves and these areas of no waves. We can visualize it perhaps a little bit better with water waves, but the same phenomenon can happen with any waves, including sound waves. So it is quite conceivable, if you set it up correctly, that you could get two sounds produced near each other and get areas of constructive interference where the sound is louder, but you could also get similar areas of destructive interference where the sound is completely canceled out. Do you know that's how noise-canceling headphones work? Who has noise-canceling headphones? Hey, I have a set, but it's an older set, and it doesn't work great, but you do notice a bit of a difference. Do you guys you notice difference on yours? Yeah? The way that a set of noise-canceling headphones work is that they actually have a microphone in them, and they detect sound, external sound. And whenever a crest is coming from an external sound, then the headphones electronically generate a trough. So it's not like saying it blocks the sound out. It's like saying the headphones are injecting another sound into the mix. When there's a crest of a sound wave or a compression of a sound wave, the headphones inject a trough or a rarefaction of the sound wave. So the crest and the trough destructively interfere, and what do you end up hearing? Nothing. It cancels out the crest from outside. Does that make sense?